Hi, it's Professor Zimmerman again, and I just wanted to cover a couple of fairly frequently confusing points related to potential energy. And in particular, I want to start off talking about the concept of conservative forces versus non-conservative forces. The primary difference between a conservative force and a non-conservative force is that a conservative force conserves energy, a non-conservative force doesn't conserve energy. A really easy way to think of this is in terms of energy dissipation. So if you imagine taking a book and shoving it across the table, well, clearly as the book moves across the table, there's a force acting on it that's slowing it down. What's happening? Well, the table is heating up. So we have this energy being dissipated from the system. What's really happening is mechanical energy is getting turned into thermal energy. So that would be an example of a non-conservative force. And in fact, in physics, in this physics class, really the only non-conservative force that we're going to deal with is friction. Occasionally we may bring up air drag. All the other forces that we deal with we can consider conservative. Another way of thinking of this is, the example they give is the work doesn't depend on the path you take. I don't know if that's a real intuitive way of thinking of things. I think it's a lot easier to think in terms of the dissipation of energy and focusing on the fact that really only the friction force and drag forces are pretty much the only non-conservative forces that we have. If you go down to the microscopic level, really all forces are conservative. The dissipation that we see when we deal with friction, when we deal with drag, comes about because we have these microscopic atoms and molecules that make up matter. And so when this large macroscopic object interacts with the microscopic, we can get some of the what we've been calling kinetic energy being transformed into microscopic kinetic energy. That's really all a non-conservative force is doing. Energy is not being lost. It's being converted from something useful like kinetic energy or potential energy into something that's not quite as useful, which is thermal energy. We'll talk about that a little bit later on, why thermal energy is not quite as useful. But that's the primary difference between the two. And you really don't need to focus on it too much. Just keep in mind that the non-conservative forces are primarily friction and drag. The other point that I really wanted to touch on in this mini lecture is we have here two different ways of expressing the gravitational potential energy. We have the near Earth and the general expression. The general expression, that's the actual formula. The near Earth expression is an approximation. And this is what we use when we're dealing with things where you're only moving, a few meters or 10 meters or even 100 meters. When you start moving farther distances than that, you start to need to this equation right here. I'm not going to go through the derivation to show that these two are equivalent, but they, in the case of moving very short distances, these two equations do end up being essentially the same thing. So, how do you know which one to use? Well, really, context matters. So the easiest thing is if we're talking about something on the Earth. Right here they say near Earth. If you're talking about something near the Earth, if you're lifting a ball up, if you're tossing something in the air, it's going to be this first equation right here. It's going to be the simple equation. Really, the only time that this general equation becomes important is when you start dealing with astronomical objects. When we deal with say a planet and a satellite or a couple of planets or whatever, that's really the only time you're going to have to focus on this. So this really is your go-to formula. This is just going to be special cases. But again, keep in mind, this is the true equation. These here, the true equations, these are just approximations that work really well and make our lives a lot easier. So there haven't been too many questions on this topic, so please try to generate some questions so I can have a much more in-depth follow-up to try to help you out as best as possible. So please keep your questions coming, and good luck.